Boys and girls, our power up subject for today is patterns. We're just going to review it. It's SOL 4.15 and it reads, I will recognize, create, and extend numerical and geometric patterns. So you have to be able to look at the patterns. Sometimes they will ask you to create a pattern and now extend, and know that that will happen with the TEI problems where you'll have to click and drag to create a pattern or extend a pattern. Numerical means in number form, and geometric can be pictures of any kind. Geometry deals with shape, so it's usually a shape pattern, but you can have any kind of picture. I will understand that patterns and functions can be represented in many ways, described using words, tables, graphs, and symbols. So you may see them in the form of a graph or plugged into a rectangle or square to look like a table, and they can also use symbols. And we've talked about the function machine, so that's what we talk about, functions. They can use operations. I will understand that patterns can be repeating, meaning that the pattern unit basically repeats itself. It does the same thing over and over again, or a growing pattern. But remember that those growing patterns don't have to always go in the positive and become bigger. They can also go in the negative direction and become smaller. And I will describe the patterns I see in words. And that's when we translate our patterns into the letters of the alphabet, like we would do in a poem when we talk about a rhyme scheme, or when we say the words that match the pictures that we see. And you'll see some examples of that in the ones that we're going to do. Okay, I want you to use your handout and follow along. The first sample shows this question. The first 10 shapes in a pattern are shown below. If the pattern continues in the same way, what will be the next 2 shapes in the pattern? Remember, one important thing that we have to do every time is annotate the question. Doesn't matter the subject, math, science, social studies, language arts. You are always supposed to annotate so you know you're answering the question that they're asking you. And so I'm just going to move it along quickly. The 10 shapes are what we're looking at. They already tell you that it forms a pattern, and then they're telling you that the pattern is going to continue in the same way. That would have been a good word to get there too. What will be the next 2 shapes? And a lot of people miss the pattern questions excuse me, because they did not read them correctly. You have to know how many shapes out they want you to count. Sometimes it will say what will be the 15th shape, what will be the 12th shape, and then you have to count how many you have to know which ones they're looking for. But now they just want the next 2 shapes. So sometimes it will be 1 shape, this time it happens to be 2. I think one of the easiest ways to attack a pattern is to turn it into letters, so that you either can hear the pattern and visually see the patterns, because sometimes it won't be so obvious when you look at it what the pattern is. And so I've kind of done what you do with the poem here. So for every new shape you have, you use a new letter. So A is the arrow facing upward, B is the open circle, C is the shaded circle. D is the arrow facing downward. We can't give it an A, even though it is an arrow. The arrow is facing in the opposite direction, so we have to give it a new letter because technically it is a new shape. Then again, B comes again, then C, then we go back to A. Then B, C, D. So if you see the unit that repeats here, it is actually A, B, C, D, B, C, and then that whole unit there repeats itself again. We've gone back to A, B, C, D. So what would be the next 2? If you look here in the original pattern unit, after D comes B and C, because this right here is the repeating unit in the pattern. So B and C are next. And then you can actually draw B and C in there to see if it makes sense that that would be the next two shapes. And it does complete the pattern that's already started. Let's move on to question number 2. Look at the pattern below. What will the next shape be? What will the 15th shape be? Then describe this pattern with words. Is this pattern a repeating or a growing pattern, and how do you know? Again, we're going to annotate it, just moving through quickly. And then we're going to ascribe letters to the pattern. A, B, A, B, B, A, B, 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 A, B. So if you look at the unit, you can see it's sort of repeating, but something else is going on here because it's not the same. It's not just that A, B again. They have added another B each time. So this time there's one B. Next time there's two of them. Then three. And you can also say this in words: triangle, oval, triangle, oval, oval, triangle, oval, oval, oval. So it would seem that the pattern is what we call a growing pattern, because the number of B's in there are getting larger by one each time. And so the next shape would be a B. They didn't ask about 2 or 3 shapes out, so they don't want to know that 4 come yet. They just want the very next shape. Okay? The next part of the question asks you what shape number 15, the 15th shape would be. So then we have to count how many shapes we already have, and here you see there are 11, and include up to 15. I normally put spaces on mine so that I can actually write out the pattern to show which one will be 15th. Just continue the pattern. And when you do that, again, we have our 1B here, then 2, then 3. So now we need 4 B's here if the pattern continues in the same way as that growing pattern. So there are 4 of them. And of course, what comes next? A triangle. So the 15th shape will be a triangle. And we could describe this with words, just saying it's an A-B pattern. That would be describing it with letters. But technically it's just triangle and oval, and then the next time we have an oval it's +1, and this is in fact a growing pattern. Take a look at the next one. Again, patterns don't always have to be geometric like the first two. They can be numeric, and this one happens to use a number line because numbers often appear on a number line in math. So now we have to find the location of point X on the number line below. They've only numbered some of the points on the line, so you would have to figure out where point X is. What number represents point X? Let's start with letter D. One thing that we notice here is that the numbers going to the right are getting larger. So obviously our number has got to be larger than 33 because it appears to the right of 33, because here's 41 and there's 45. The numbers to the left are getting smaller. So it would have to be less than 41 but greater than 43, which all of these are. So far all of our answer choices are fair game, and we can't eliminate any choices yet. If we continue and try letter D, we have to fill in the numbers. So if this point was 40, because that's one of the answer choices they give us, and this is 41, then this would be 42, the next is 45. And as you can see, that's not the correct order of how we would say numbers, so that can't be the correct pattern. So we would eliminate that answer. So we can try the next one. A is 36. If we're going to use X as 36, then this one would have to, there would have to be some skip numbers in between 36 and 41. which would be 37, 38, 39, 40, because you keep counting the regular way that you would count. Next comes 41. And we skipped 4 numbers between 36 and 41, so if it's a pattern, it will do the same thing. It should skip 4 numbers. But look what happens when you try to skip 4 numbers in between. 42, 43, 44, we've already reached 45, which is here on the number line. So that wouldn't make any sense. We haven't even gotten to our next point on the number line, and we've already come to 45. So we cross out 36 because it doesn't work. We try it again with 37. Again, 38, 39, 40. If we're getting to 41 here, it has to skip 3 in between each of those points. 42, 43, we're already at 44, which means 45 would have to be here. 46, 47, 48, and this would actually be 49. Again, does not work. So let's try 39. If we put 39 as point X, then 40 would be skipped, and we would go to 41 as the next point on the number line. 42 would be skipped, then we would go to 43. 44 would be skipped, and then we come to 45. And when we do it that way, we notice that that pattern fits what's actually going on our number line. And the best way to determine whether a pattern fits, oftentimes, is just plug the numbers in and try them. Does it work? You can't force it to work, but if it actually works when you try the pattern, then that is your answer. Here's another format. This time it's in a table, and we've seen some like this before. And remember, it's important to read it so you understand which way to read the table. The table below shows the total cost of the different numbers of notebooks, kind of like that paddles and canoe things. So here's the number or the cost of one notebook. One notebook straight across costs $3.50. So that's the direction you should be reading this, horizontally across. Number of notebooks, total cost. So if you have 2 notebooks, how much is that going to cost? Well, $7, because each one again cost how much? $3.50. Okay, so 3 notebooks would mean you would take that $7 and add another $3.50, because each notebook costs $3.50, which would bring you to a total of $10.50. Now beware, it doesn't always work out this way. On this particular chart it does, but it may not be as simple as that in some problems that you'll see, and so you'll have to figure out how much it increases by every time. It won't always increase by the cost of that one notebook, so be careful that you don't always think that that's the pattern. But this one happens to be. So 3 notebooks cost $10.50, add another $3.50 to it, and 4 notebooks will cost you $14. Again, remember that these questions are going to be on the calculator ready part of your test. And so what you need to do is make sure you use your calculator to find those answers. So if we put it in, 350 plus 350 equals $7. Add another 350, and you'll notice the 0 disappears just before, because it's a calculator, it doesn't mean you've done it wrong. 1050 plus $14. Sorry, plus $7. 1050 plus 7 plus 350. Jeez, it's late. Sorry, ladies and gentlemen. 1050 plus 350. Remember, the calculator doesn't make choices for you about answers. It can only do what you put in. So it's a good example of what not to do with the calculator, because if you put in the wrong numbers, it will absolutely give you the wrong answer. So now we're to $14 plus another $3.50 gives us right here $17.50. Now they want to know what the total cost of 6 notebooks will be. Well, there's no space left on our table, but still they're going to ask us about 6 notebooks. And that will often happen, that it will extend beyond the table. So you'll have to either create your own or write in your own. So take that 1750. Here's your 6 notebooks. Add the 350 for the new notebook. Use your calculator, and you actually get 2150 as your answer. And now they make a big jump here. They don't just go 6 to 7 or 8. They want to go all the way to 10. One way you could do this is to actually go 7. Add your 350, get your answer. Then 8. Add your 350, get your answer. Then 9, and then 10. Or because they're using an exact pattern with 350 being the cost of each one notebook, and you'll have to work that out and make sure that's the case before you try it this way. An alternative way to do this would be just simply to multiply the cost one notebook by the number of notebooks you're going to purchase, which would be 10 notebooks. And I'll use the calculator quickly just to show you, but this should be an easy enough one for you to do. If the calculator would open behave. But again, each notebook costs $350 times 10 notebooks gives us $35, ladies and gentlemen. And that is your answer for 10 notebooks. Again, reading the question carefully to know what the pattern is they're showing you and how you should read that table is essential. One notebook, $350. This one we read horizontally. And so it goes on. And then understanding what the relationship is between each of these numbers. Don't just assume that because one costs $350 that two is going to cost $350 plus another $350. Does this time, but it won't always. So beware of that. Next one, and the last one, is our function machine. And this function machine uses a rule to change numbers into other numbers. The pictures below shows what happened when the numbers 4, 12, and 7 went into the machine. So we put 4 in, we got 32 out, 12 in, we got 96 out, 7 in, we got 56 out. They want to know what the rule is. And then, of course, they extend the question to ask you what happens if a 9 goes in there. And sometimes they will do that. So be careful. Remember, with the type-in answers now, these questions can become more than just finding a multiple choice answer. So if it's a TEI, you'll actually have to type in the answer. Let's take away our highlighting for 1 minute just so we can take a closer look at this function machine. We are putting in a 4 and getting out a 32, a 12 and getting out a 96, a 7 and getting out a 56. What are the numbers doing? That's right. If you answered getting larger, you are absolutely right. And Math Ninjas, what are the 2 operations we can use to make a number larger? If you answered multiply or add, or multiplication and addition, either one of those, you are absolutely correct. And so what we have to use is the pattern of either multiplication or addition to try and get the new number. So we can ask ourselves 4 plus what number gives us 32. We can either do it that way and try to guess at a number that will get us closest to 32. Or remember, we can always use the inverse operation, which would be 32 minus 4. Remember, subtraction is the opposite of addition. 32 minus 4 gives us 28. So 4 plus 28 gives us 32. Again, using the inverse operation to actually find the answer. So now we'd have to take that 28 and add it to each of the others to see. 12 plus 28. Again, use your calculator. It's available to you. 12 plus 28 is 40. And we know that that does not work. So the first one worked, the second one did not. But we have to go on and try the third one. 7 plus 56. Let's try that one. Sorry, before we move on, just to see. And we'll take out our calculator. Again, behave, Mr. Calculator. 7 plus 28 equals 35. Again, not our right answer, which we want, 56. So we know addition must not be the answer to this one. So now we're going to have to try multiplication. And if you know your multiplication facts, you can ask yourself 4 times what number will give me 32 as an answer. Or if you know your division really well, which I know is a little difficult sometimes, you can try the inverse operation. 32 divided by what number gives me 4? Or 32 divided by 4 gives me what number? That will also work. So we find 32 divided by 8 gives us 4, or 32 divided by 4 gives us 8. Remember, it's a fact family. So we can actually see it either way. 32 divided by 8, and sorry, it doesn't, there is no division sign on there, so you would have to 32 divided by 4 equals 8. You'd have to write it as like a fraction on the diagonal. That is the division sign, ladies and gentlemen, on a computer. This symbol right here, the backslash there. So 32 divided by 4 equals 8, or 32 divided by 8 equals 4. So when you use that to find the number you should have multiplied by, 4 times 8 is 32. Or hopefully you will know your multiplication facts soon and figure out that that is the answer. Again, if you didn't know how to do it that way, what you could do is use your calculator or just use addition, and we know multiplication is just repeated addition, so you do 4 plus 4 is 8, and then you add another 4, it's 12, and then you add another 4, is 16, and you would just keep going until you've done this and you have 8 4s all together, excuse me, which will add up to 32. Okay, so you've now found out that 4 times 8 is 32. You'd have to check the next one. 12 times 8 is what? It is 96. So the first two check out. Remember, in order for it to be a pattern, function machines use the same operation, also the same number, and so it has to work with the last one using that same operation and number that worked with the first two. So let's try it. 7 times 8 again is 56, and look at that, didn't know that button was there. You'd have to use your little trusty calculator if you didn't know it. Some of these questions will use the calculator, others will not, ladies and gentlemen. So 7 times 8 is 56. Now, talking about the rule down here, we can explain it, and there's a really easy way to explain it. If you look at all of them, what did we do? We multiplied by 8. So we would put our rule as multiply by 8 because the number is increasing. If you wanted to put that down as your explanation, and we know we could only use addition or multiplication. We tried the addition didn't work, so multiplying by 8 is what gave us the answer to all of them. And then what number comes out of the machine if a 9 goes in, and again if we multiply using our calculator, 9 times 8 is 72, or you could do your little hand trick with your 9s, 9 times 8 equals 72. So, just to wrap it up, when you use patterns, make sure you look closely at the question. Know that it could be numeric. It could be geometric. They may ask you to go one shape out. They may ask you to put the 18th shape, but you need to continue the pattern until you get to that one. Look for the repeating unit. Is it a repeating or is it a growing by chance? Now we can call this a growing pattern because the numbers are getting larger. When dealing with a function machine, remember that function machines are pretty easy because they use the same operation and the same number for every one of the problems they're going to give you. when you're looking at a question that has a table, be sure you decide how to read that table. Are you reading it horizontally? Are you reading it vertically? And there's usually a pattern. So what is the pattern? Figure out the pattern that helps you to continue and complete the table. Going backwards. Number lines. Plug the numbers in, each one of them, to the number lines. That's the best way to treat each and every question that you use for a pattern, is to try the numbers in the pattern. If it works for all of them, then it works. And if it doesn't work for some of them, then it does not work, because the pattern works on the premise of a rule. And the rule has to be applied to each part of the pattern in order for it to work, or to each of the ones that they give you. So, ladies and gentlemen, I hope you learned a lot about patterns, and hopefully you'll apply it, and always annotate and double check your answers. And for heaven's sakes, use the calculator if it's available. See you in class.